Hello there, welcome back. This is another Algebra 1 video, and this video's focus is going to be on how we can figure out the number of solutions that an equation has. So when we're trying to determine the number of solutions an equation has, we have three options. The first one is no solution. That means this equation has no solution. The other option is one solution. That's our typical thing that we get when we're solving equations. Q equals something. The other option is infinitely many solutions. And what that means is another term you may hear for this is called all real numbers. What that means is that any number could be equal to the variable. So when you would substitute in any number into the equation for the variable, it will be balanced on both sides or equal on both sides, no matter what you use. So the way that we kind of determine this is we start by eliminating the variables if we can. If we eliminate the variables and we get an untrue equality statement, like 3 equals 2, that means there is no solution to this. If we eliminate the variables and we get a true inequality or a true equality statement, like 3 equals 3, then that means it is infinitely many solutions. That means all real numbers work. Now, if we get something like this where we can't eliminate the variable, so we end up with Q equals 1, then that means it has one solution. So let's go ahead and try it with this one right here. So let me delete those things, and then I will kind of rewrite the equation here. So what we're going to try to do is get rid of the Q if we can. I'm going to start by combining those Q's together and moving this Q to the other side of the equation. And I'm going to go ahead and draw that line to show where the two sides are. So I'm going to add Q to both sides here. These Q's will eliminate. I'll have -2 over here, and then -2 Q's plus a Q leaves us with -1 Q's or negative Q. So now if I go ahead and divide both sides by -1, I end up with 2 equals Q, which means that this equation has one solution. I was not able to eliminate the variable. Okay, here's our next one. I'm going to try to eliminate the variables so I can see how many solutions this equation will have. So what I'm going to do is take this -9d and move it to the other side of the equation to put it with the other d. So let me go ahead and draw the line here. I'm going to add 9d to both sides. So it moves across the line. I have to do the opposite to both sides. This cancels out, but so does this. So now my variables are eliminated, not limited, eliminated. 0 equals 10. That is an untrue equality statement. 0 does not equal 10. So that means this equation actually has no solution. Okay, here's our next equation. We're going to try to see if we can determine how many solutions it has by eliminating the variables. So we have 19Q and 19Q on both sides. So what that means is I can subtract 19Q from both sides. And it really doesn't matter which one I do or where it moves, it's going to be the same. So 19Q minus 19Q. And that eliminates the variable from both sides. That leaves me with the statement that 16 is equal to -15, which is not true. So that means this equation has no solution. That means no matter what number Q is equal to, that it will never be a solution for this equation. Okay, here's our next one. We have this equation 2.6p equals 9.3p minus 6.7p. So lots of p's going on here. So I'm going to start first by combining these two p's that are together on the same side. I'm going to put 9.3 minus 6.7, and I end up with 2.6. So this is 2.6p, 2.6p. So you might be thinking, oh, those variables are going to eliminate. They actually aren't, because what I'm going to do is I'm going to divide 2.6 divided by 2.6. Actually, I don't even need to do that. Just kidding, because I already have, even though I didn't eliminate the variables, I already have a true equality statement. 2.6p does equal 2.6p. They're exactly the same. So we're going to go ahead and just call this infinitely many solutions. That means no matter what p is equal to, it will work for this equation. Okay, here's our last example for this video. We have 6.9b minus 6.9b equals 0. So I'm going to go ahead and draw the line here. I'm going to combine these two variables or these two terms that have b's on them because they're already on the same side. If I take 6.9 and I subtract 6.9, I actually end up with 0. So I have a true equality statement. 0 does equal 0. So that means infinitely many solutions. That means that no matter what b is, it will work for this equation. All right, you guys, thank you so much. And I hope to see you in another video soon.